In this video, we are going to be taking a look at solubility graphs. All right, so each of the curves on the graph is going to represent the solubility of the compound in 100 grams of water throughout the entire temperature range of 0 degrees Celsius to 100 degrees Celsius. So from 0 degrees Celsius to 100 degrees Celsius, this is going to be the temperature range of liquid water. So remember that at 0 degrees Celsius, water will freeze. At 100 degrees Celsius, water will boil. So we're not able to dissolve anything in the frozen or gas state. The area above the curve is going to indicate when a solution is supersaturated. So if our point is above the line, that means that it is a supersaturated solution. That means that there is more of the solute in the solvent that it is able to handle. An example of a supersaturated solution is going to be whenever we add sugar to water, and whenever we keep on stirring or we keep on heating up the water and it is no longer able to dissolve, that sugar is supersaturating the water. Now, the area underneath the curve is going to indicate a solution is unsaturated. This means that the solvent is able to dissolve more. This is going to be an example when we first put sugar into water, we're able to continuously dissolve more and more sugar until we reach a certain point. Now, the line itself is going to mean that it is saturated. The saturated amount is going to be the maximum amount that is able to be dissolved in a solvent, or in water in this case. Now, the solubility of most solids increases as the temperature increases. This can be seen with salt or sugar. As we increase the temperature of our water, we're typically able to dissolve more and more of our solute, the sugar or salt. Now, the opposite is going to be true though for gases. The solubility of gases will decrease as the temperature increases. This is especially important whenever looking at ocean or marine biology. A lot of the larger fish are going to be located at colder temperatures, and that is because that oxygen is going to be dissolved more and more available at colder temperatures. Now, as the temperature of water increases, it is going to release those gases that are dissolved in it, and they're going to release it into the atmosphere. Let's go ahead and take a look at our different solutions and what would happen if we add a salt crystal to the following solutions. Now, looking at first at an unsaturated solution, if we have an unsaturated solution, that means we are able to dissolve more. So if we were to add a salt crystal in an unsaturated salt solution, we are able to dissolve more of that crystal. So in an unsaturated solution, we are able to dissolve more. Now, if we were to put a salt crystal in a saturated solution, now remember that a saturated solution means that it has reached the maximum capacity that it is able to dissolve. So what will happen is that it is going to end up sinking. So it will sink and will not dissolve. Now, for a supersaturated solution, this and everything is going to be especially interesting because a supersaturated solution is whenever we force more of the solute to dissolve in a solution than what its maximum capacity is. So we're kind of forcing that solute to dissolve in a supersaturated solution. So if we happen to add an additional salt crystal into a supersaturated solution, it is actually going to cause it to recrystallize. Now, The most often times that we see a supersaturated solution is going to be with hard candy, like a Jolly Rancher. So in order to make a Jolly Rancher, what you create is a supersaturated solution of sugar, and you keep on adding that sugar into water until it can no longer hold any more. Then what we do is that we start to cool it down. And during that cooling process, that sugar is going to recrystallize and form a hard candy. Let's go ahead and take a look at our solubility graph. So off on the right, we have a solubility graph. We'll notice that at the bottom, our temperature is in our degrees Celsius. Over to the left, it will be our grams of our solute per 100 grams of H2O. So our temperature going from 0 degrees Celsius to 100 degrees Celsius. And then our grams of our solute is able to increase quite a bit. For example, in this chart, we are going from 0 degrees Celsius all the way up to 150 grams. So 0 grams to 150 grams of our solute. Now this is per 100 grams of water. Now, our first question is asking, what is the solubility of KNO3 at 50 degrees Celsius in 100 grams of water? The first thing that we're going to do is that we are going to need to figure out where our line is for our KNO3. Now, our line for our KNO3 is located right here. So that will be our KNO3. Now, we are going to be at 50 degrees Celsius. So down here at the bottom, we're going to look at 50 degrees Celsius, and we're going to go all the way up until we reach this line. So this is going to be our intersection. And then we look over to the left to figure out how many grams are able to be dissolved. So at 50 degrees Celsius in 100 grams of water, we're going to be able to have 80 grams of our solute. And that is going to be the answer for this question. Let's take a look at our next one. This is asking how much of our NH4Cl can dissolve in 100 grams of water at 90 degrees Celsius. So we are going to go ahead, we are going to find our NH4Cl line that is located right here. We are going to be at 90 degrees Celsius. Go all the way up until we reach that line. We'll find this intersection, read it all the way over to the left. And what we'll notice is that we should be able to dissolve 70 grams of our NH4Cl at 90 degrees Celsius. So this will be our 70 grams. Looking at our next question, if 80 grams of our KNO3 is placed in 100 grams of water at 40 degrees Celsius, is the solution unsaturated, saturated, or supersaturated? So we're going to look at our KNO3 line again. That is located right there. We are going to be looking at 40 degrees Celsius at 80 grams. So 40 degrees Celsius, in this case, we're going to go ahead and put a line all the way up. And we are provided 80 grams. So looking at 80 grams over to the left, and we'll notice that these two lines are going to intersect at that point. Now, because it is over the line, this is going to be considered to be a supersaturated solution. So that is going to be a supersaturated solution because the intersection at 40 degrees Celsius and 80 grams is above the line. Now, if it was below the line, it would be considered to be unsaturated. If it was on the line itself, it would be considered to be saturated. Taking a look at our next question, which solute is saturated when 20 grams of the solute is dissolved in 100 grams of water at 65 degrees Celsius? So this is asking for which of our chemicals is located at 20 grams at 65 degrees Celsius. So 20 grams at 65 degrees Celsius. So we are going to be at 65 degrees Celsius, which is right here in the middle. We're going to go ahead, draw a line all the way up. So that will be our 65 degrees Celsius. Now we are going to be at 20 grams. So we're going to look all the way over here. And we'll notice that the intersection of these two lines is on this point. Now, we will notice, kind of following this line back, this is going to intersect with the line of our NH3. So this means that our NH3, if I have 20 grams of it, or I'm able to dissolve 20 grams of my NH3 at 65 degrees Celsius. Taking a look at our next example, it is asking how much KClO3 can dissolve in 200 grams of water at 0 degrees Celsius. So we are looking at our KNO3 at the moment. We are at 0 degrees Celsius, so we're going to draw a line all the way up to right here. All right, taking a look at our next question. It is asking how much KClO3 can dissolve in 200 grams of water at 0 degrees Celsius. So we're going to look at our KClO3. So that line is located right here. We're at 0 degrees Celsius. And so our initial point is at 5 grams. Now, this is going to be 5 grams at or in 100 grams of our water. Now, what we'll notice, though, is that the question is providing or asking us in 200 grams of water. So in this case, we're doubling the amount of water that we have. So because I'm going to double the amount of water that I have, I also need to double the amount of our solute. So it'll be our 5 times 2. So this will be our 10 grams in 200 grams of water. Taking a look at our next question. It's asking which salt or solute has the most rapid increase in solubility if 100 grams of water is heated. So we're going to be taking a look at the chart overall, and we're going to find whichever line is increasing the fastest. Now, if we take a look at the chart overall, we should notice pretty quickly that the line that is increasing the fastest is going to be our KNO3. So this line right here has a really steep slope to it. So it is going to be the most rapid increase in our solubility. So this will be our KNO3. Taking a look at the next example. The solubility of which two salts is identical in 100 grams of water at 95 degrees Celsius. So it's asking for our salts at 95 degrees Celsius. So looking at 95 degrees Celsius on our chart, drawing a line all the way up, we're going to find when two lines are intersecting with each other. And our two lines are intersecting at this point right here. Now, we should notice that the lines that make this intersection come from our KCl and from our KClO3. So those two lines together are going to intersect at 95 degrees Celsius. So it'll be our KCl and our KClO3. Looking at our next question. It is asking if 50 grams of NH3 is placed in 100 grams of water at 10 degrees Celsius, is the solution unsaturated, saturated, or supersaturated? All right, so we're taking a look at our NH3. We'll find that on our line, on our chart. So our line of NH3 is right there. We're at 50 grams. So we'll draw a line all the way across, and we're going to be at 10 degrees Celsius. Go all the way up. So we'll notice that the point is underneath the line. So because this point is underneath the line, this will be considered to be unsaturated. Taking a look at our last problem, it is asking which of the gases or which and everything of our solids on our chart are going to be gases, and explain our answer. So this and everything is going back to what we talked about at the top of our page. So the solubility of our solids will increase as we increase our temperature. However, gases will typically decrease in solubility as we increase the temperature. So we're going to look at our solids that are decreasing on our solubility chart. We are going to be looking at the lines that are decreasing, and we should notice that there are only two lines that are decreasing on our solubility chart. This is the NH3 and our Ce2SO43. Both of these lines are decreasing on the solubility chart, making them most likely a gas. So it's our NH3 and our Ce2SO43. So because they are decreasing in solubility as we increase the temperature, they are most likely a gas.